Hi, we are the group number 3 and we talk about workshop number 3, odometry. For this workshop, we have three objectives. Now the concept about odometry and kinematics on differential robot, calculate the odometry of a robot using MATLAB and LEGO EV3, and visualize the robot trajectory using graph on MATLAB. Abstract. For this practice, we use a LEGO Mindstorm EV3 for understanding how to control a differential robot. We establish a kinematic model and code a set path for the robot to accomplish. Then we check the output and compare to the theoretical data to identify a possible improvement of the kinematic model. Introduction. Odometry. Odometry is described as estimation of position and orientation, also called pose, adopted for the robot. In other words, odometry is a method that the robot uses to measure the distance they have traveled and their current position, using the information from the wheels and mathematical calculation. For this, we must establish some assumptions. Each wheel has one contact point, no slide pitch and no sliding. Commonly, odometers can replace unreliable external sensors like GPS or can work with them to improvement the absolute and local positioning. Thank you.
As for the methodology that we use, first we obtain the kinematic model of our differential robot. As it is shown, we got the two equations, one that refers to the linear velocity of the differential robot and the other one to the orientation, where omega 1 and 2 refers to the angular velocity of both wheels of the robot and R2 the wheel radius. Next, we measure our differential robot's parameters, such as its wheel radius and axle length. These details will be used to calculate the future linear velocities and its important odometry data for future analysis. As for the implementation of the code, we use MATLAB with the EV3 library to program our model. First, we set up the parameters, configure motors, and establish USB communication with the program. Next, we have to create distance measurements and velocity calculation variables. For then, we can initialize robot movement and update its odometry variable with its new position and orientation for later analysis.
Birds that have at uh, orange dots, that's intent trajectory. That's the trajectory that like they follow this robot. And the second one is the real trajectory. That trajectory is the the robot, the trajectory robot following and sends her her position with a sensor. We can see how the robot differs her position or respect these trajectories. And we can attribute this error has accumulated error, respect different points. In this case, for the analysis, we have to tend to take uh, many factors, such as will stage page, inaccurates in the measuring angle velocity, errors in the engine calibration, and non-uniform terrain. That factors are not considered in the cinematic model that presents before this analysis. That's the reason the robot don't follow the trajectory that initially tried to intend.
Now for our review, we can conclude that we learned how to establish a differential robot kinematic model by describing the equations of movement for each wheel. And we use MATLAB to create trajectories that we later compare with the reality. Um, Now we can make some adjustments in our model for being closer to what we expect the robot movement should be. Um, for this particular reason, for this particular things, we recommend to use some extra sensors that will help us with those estimations. Um, we also recommend to try different values in our mathematic models, so we can be closer to reality. And we also recommend to use some algorithm for corrections, like comments. Well, thanks.